Welcome back to the Functional Python series. In this video, I want to start a sub-series of videos in which I will be solving Kattis problems using the principles and the techniques that we have learned through the series. So let's get started. I'm going to solve the problem called Milley-Fires-La. But before we go into that, let me explain a little bit of what the challenge is. Functional principles are relatively simple. We have talked already about lazy computation, how we can use streams, and we have lots of operations to work on these streams, filter, map, etc. There is another principle that we haven't really talked about directly, which is no mutation. The idea is that once a variable is set, we don't want to change its internal state. Okay, I'll talk more about that in the future. And the real challenge in functional programming is not learning it, but learning to apply it, learning to use it. So the objective of these videos is to start creating some drills so we can start getting used to the constructs and see where they can be used to solve particular computational problems. I really like Kattis, which is a website of repositories. It's intended for competitive programming, but I think that it's also a great resource to learn to program. Kattis has literally thousands of problems, and each one of these problems is ranked by difficulty. Let's order it from lowest to highest. The simplest problems, for example 1.1, etc., are relatively trivial to solve. And I think that when you're learning a new language or a new way of approaching problems, this is an extremely valuable resource. So we're going to do that today. So we're going to solve this problem. Let's say that I don't want it. Milley-Fires-La. Go to the link in the notes. They are in GitHub. The URL is in the description. You can go here, you can read the description. Stop the video if you want to. But I'll give you a very, very quick overview. The idea is to read three numbers. Each one of these numbers is associated with a different string. Money, fie, and $bi, yol. Sorry if I mispronounce it. And the idea is to find the smallest of these three numbers and print its corresponding string. So for example, if I'm given 3, 9, and 7, 3 is the smallest and money is the corresponding string, so I print that. If I'm given 3, 2, 3, 19, and 999, then I'm expected to print fie. And here's one extra requirement that I'm imposing. Can you do it without any comparison? Solving the original problem is very, very easy, but can you do it without any comparison? So stop the video now, think a little bit about how you would approach and solve the problem, and then continue playing it. Okay. Let's go to my solution. I have already set up the names. So I have created this file and I have the input cases from Kattis. Okay. So here are the three examples. So let's get started. So the first thing I need to do is I need to read three values. So in fact, what I need to do is something like this. Input, and then do the same for B and then C. And then I can start operating with them. But this makes the code harder to read, more difficult. So instead of this, what I really want is a stream of values, in this case 3. Okay. So how can we achieve that? Well, sys.stdin is a stream that every time that we request a value from it, it will return the next line in a standard input. So we can do something like this. We can do, my data is going to be stdin, so I need to do my import. sys. And then if I print the data, this is what's going to happen. So input 1. So it prints basically the wrapper. So when we want to debug this, the best way to debug it is, let's convert this data into a list of data, so we can see what it is. As you can see, we read 3 strings. So strings are not very useful because I have to convert into integers. So let's do that with map. So we can convert the data into ints. And if now we print it, we get 3 numbers. Perfect. Okay, so now I can find the minimum and then try to track in which position it is. But that would be a little bit complicated. So I think that the best solution, or the best way to proceed at this point, is to get something like this. I want to have 3 tuples where the first value of the tuple is this. The first tuple is this. The second tuple is the one corresponding to the first element, the second element. And then the third tuple is the one that corresponds to this. Okay. And I can do this with another operation in the library itertools. So itertools, and we'll have a video dedicated just to it, provides an operation called zip. So what I want to do is zip. Think of it like a zipper, where one side is data and the other side will be names. Okay. So let's run it and see what happens. Perfect. So now I have each one of the values and its associated name. Okay, so what do I do next? Well, I don't really like to have tuples because I have to remember in which position do I have what. So let's write more maintainable code. This is not necessary, but I think that it helps. So I'm going to create a record, which is from collections, name tuple. And this records a name, so it can be anything. So, and then the names of the record. So it's amount and name. That's basically from the description of the problem in Kattis. Okay. So how do I take my data and convert it into a stream of records? Well, all I need to do is do a map. And in here, a lambda makes good sense. So we want to call record, and we want to pass the tuple as the parameter to record and data. Okay, so let's print what we get now. Now we have 3 records, each one with an amount and a name. Perfect. I don't have to remember in which position I have which. So now I can do and say, give me the minimum of them. I want the minimum. And here's where I can use the function min. Min takes a list of things and returns the smallest. Now records are tuples. So it will take the first element of the tuple and it will say, well, what's the smallest of the first records in this list of tuples? And then return that corresponding tuple. In this case will be the record. So let's run this. Perfect, I get Monet, which is the value that I expect. Fie for the second test, and $billion for the third one. $billion for the third one. Okay, but I don't want the entire record. All I want is the name. So let's remove actually our debugging statement. So what I need to print is data.name. Okay, let's run it. And I get the name. Okay, perfect. So let's see what Kattis thinks, whether our solution solves the problem. So let's go back to Kattis. Let's select Python. Actually, we can upload the file. It will detect it by itself. So let's go where I have these files. And let's submit it. It's passing. Good, good, good. It's getting there, almost there. Looks like it's working perfect. Great, it was accepted. So let's go back to the description. And let's go back to our solution. So our solution is good, it works. And so let's go back to the editor and let's just discuss just a little bit more about it. So there's some things that I really want you to pay attention to. First of all, I never really modified the state. I kept using this name data, and the reason was basically I didn't want to create a new name for each one of the lines of code that I had. But essentially what I did was take the input stream and start transforming it one operation at a time, until I got the final result that I wanted and I printed it. There are very few places where this program will be incorrect. Each one of these lines is relatively simple. It's one of my production line stations. Processing doesn't start until min. Min is the one that says, now go and give me the data. And in this case, zip will say, oh, I'm going to actually zip the input data with the name. So I only need 3 input lines. And so the first line, 12, just says the stream is going to be a standard input. Line 14 says, I'm going to convert each one of those lines into an int. The third one is, I'm going to zip them together. The next line is, oh, I don't really want tuples, I want records. So let's convert that into that. The next one is min, just give me the minimum of that and just print it. The errors here might be that I called the incorrect function in one of the maps. Maybe I swapped the parameters in zip, but those are relatively easy errors to spot, especially if I debug one line after the other. And then finally, by using the name tuple, then I have to actually use the name, because if I use a different string than name, I will get an error at runtime. So I think that hopefully this shows the great benefits that we have of doing functional programming. So finally, I think that learning functional programming takes practice. And so go to Kattis and start solving simple problems using functional programming principles. And if you have any recommendation for any problem that you would like me to solve, then please leave a comment and then I'll try to do that. That's all for this time, and I'll see you in the next video. Thank you.